Thank you very much, ladies and gentlemen. I'm delighted to be here. And you may wonder why, as a retired Air Force general running around the United States talking about bombings, Army, all of the development capability for developing weapons for air delivery stayed in the Army. It did not go with the Air Force. So in the early 1950s, the Air Force decided they were going to get back in the weapons development business to exploit new technology and overcome a lot of major operational deficiencies. And they set up a program for bringing after I attended this 8 quarters of graduate work in armament engineering, they give you a master's degree in aeronautical engineering, but the breadth of the course was such that they're giving a master's in almost several other areas. After I finished that work, I went to the ballistic research laboratories at Aberdeen Proving Grounds, Maryland, because at that time that was fairly much the mecca of the conventional non-nuclear weapons development area in the United States, excluding the chemical and biological. And I worked at the periphery of that circle, our sheet aluminum 4 feet by 8 feet. And you can see the panels all around the circle are being cut continuously around that circle about 150 feet in diameter. The warhead has already functioned in the center. That's about the extent of the expansion of the detonation products from the warhead. And because you had the warhead was surrounded by a heavy double layer of rods, metal rods, the detonation products went off to the end, the so-called end effect. But I bring this up to show you what a continuous rod warhead is, because it's very significant with respect to TW-800. Now, those rods, when the warhead goes off, you have an accordion expanding hoop or circle moving out 5,000 or 6,000 feet a second. Cold rolled hard steel rods, but they're at a distance you can have considerable inaccuracy in that guidance system and still destroy the target if the warhead and fusing system is compatible with the reach of the warhead. And what you do is you have a fusing system, it is looking off at an angle, and when it intercepts the target, the missile fires and the rods go out in an expanding hoop and slice across the aircraft just like a saber across the watermelon. Now you could use a fragmenting warhead, what you call a blast frag warhead, and you send out, instead of sending everything in a strong, long, continuous cut, you send it out in fragments. You may punch a bunch of holes in something and you'll destroy maybe some systems in the aircraft, but you're not going to get a catastrophic structural failure unless you hit the system. But with all-weather guidance systems, you have longer wavelengths. You're using semi-active or active radar, going after a beacon or transponder or a carrier wave, and you're dealing with longer wavelengths. You have a small aperture on the missile, so you have accuracy problems. And if you miss the aircraft 35 feet or 40 feet with that kind of warhead and with that reach and proximity fusing, you'll still slice it in two, so it doesn't matter. So if you look at the TW-800, across you can see that from this point forward, and this is the forward end of the aircraft, you have a continuous cut from the top all the way down to the bottom. And this part of the aircraft was separated from this part at that point, and the nose of the aircraft went down integrally. It wasn't torn up at all. It went down in one piece, ballistically straight down. Now at the time the warhead hit it, you had about 5 pounds of pressure for pressurization in the aircraft. So when the warhead hit it, and it cut it in two, you had instantly about 250,000 pounds pushing it apart because of the pressurization inside the aircraft. And it appears to me the first point of contact with the warhead was right here, and you can see the evident explosive decompression dropping the pressure very quickly from the first contact with the aircraft. But as big as the aircraft is, 747, it took considerably longer time for it to exhaust the gases out with the push going forward. This is a little